Welcome to the Solve Force podcast series, where we discuss and decode the technical networks that connect our world. This episode draws from Ron Legarsky's Amazon book series. Hi, we're Alex and Taylor. For today's deep dive, we are exploring the battle for attention, how our devices capture and hold us.
Yeah, and I think this is probably one of the most important things we could be talking about right now.
Absolutely, because, every single time your thumb pulls down to refresh a screen on your phone, your browser is, it's silently executing this cybernetic feedback loop.
Right, a loop that was actually originally designed in the 1940s to guide anti-aircraft missiles.
Which is just wild to think about.
Mm.
But today, that missile is your attention. So our mission today, for you listening, is to unpack this huge stack of historical and technical sources. We want to really understand the invisible digital architecture that tracks our behavior.
Exactly, and how it essentially fragments our shared reality.
Right. So we're going to trace the evolution of the web, starting from this stateless AJAX network, all the way to the invention of the cookie.
And then we'll get into the psychology of the infinite scroll and this thing we call the cybernetic inversion that basically governs modern social media.
Yeah, and just to be super clear up front, this isn't like a moralizing lecture on screen time. We're not here to tell you to put your phone down.
No, not at all. We are looking at this strictly as an intellectually rigorous breakdown of an engineering problem. It's a highly sophisticated, mathematically optimized system.
A system built to extract human attention, which is basically the ultimate finite commodity of the digital economy today.
It really is. But before we can understand how our devices hold our attention in this vice grip today, we have to look back at the original architecture of the web.
Right, because it was engineered to do the exact opposite.
Exactly. It was designed to forget you instantly.
Which connects back to a previous deep dive we did. We spent some time discussing the early architecture of Web 1.0, specifically Tim Berners-Lee's initial design at CERN.
Right, the HTTP 0.9 protocol.
Yeah. And we talked about how it was fundamentally a stateless network. But for anyone who maybe missed that recap, let's break down what stateless actually means in this context.
Sure. So in a stateless network, the server retains zero memory of the user. None.
Okay, so it's a completely blank slate every time.
Every single time. You request an HTML document, the server delivers it, and then the connection, the TCP connection, is immediately torn down.
Okay, let's unpack this for a second.
Yeah.
Because it's kind of like the movie 50 First Dates, but for a web server.
Oh, yeah, that's actually a great way to put it.
Right. Like every interaction is a completely new day.
Yeah.
The server wakes up, meets you, gives you the web page, and then goes right back to sleep and forgets you ever existed.
Exactly. If you clicked a second link on the very same web page a fraction of a second later, the server processes you as a completely anonymous, brand new stranger.
Which, seems incredibly inefficient today. But it made sense back then, right?
Oh, it was brilliant for its original purpose.
Yeah.
You have to remember, this was built for physicists at CERN who were just sharing static academic papers.
Right. They didn't need dynamic feeds.
No. And they needed to conserve precious server memory. But it was structurally hostile to the concept of a continuous identity.
Which creates a massive problem the second you try to sell something. The e-commerce bottleneck.
The biggest bottleneck you could imagine.
Because, as we've established before, a stateless network is completely incompatible with e-commerce.
Right. You can't have a shopping cart if the server forgets you between page 1 and the checkout screen.
You put a sweater in your cart, click checkout, and the server says, who are you and why are you trying to buy it over?
Exactly. The whole transaction chain just snaps.
So the industry obviously needed a memory upgrade, but once they figured that out, the whole business model shifted, right? Like once platforms eventually became free to use.
Right, because in the old days, like with AOL, you paid an hourly access fee.
Oh man, the dial-up sounds just flashed in my head.
Right. But once the platform charges no access fee, the product being sold to advertisers is the user's attention. That was the huge fundamental shift.
So to solve this amnesia problem and build this modern internet economy, engineers had to give the web a memory.
They did. But that totally innocent memory upgrade became the absolute foundation for global surveillance capitalism.
Which brings us to the invention of the cookie.
Yes, 1994 at Netscape Communications.
And Netscape was basically building the first widely used commercial web browser.
Right, and they had this client, MCI, who was trying to build an online marketplace. And MCI ran face first into the statelessness problem we just talked about.
They needed a shopping cart to work.
Exactly. But MCI actively refused to store that session data on their own servers.
Why? I mean, today's servers store everything.
Well, at the time, server storage and database lookups were incredibly expensive and super slow. If you had, say, thousands of concurrent users, forcing a database to constantly check who owned which cart would have just crashed their infrastructure.
So the engineers are caught in this crazy bind. The network demands amnesia to stay fast, but commerce demands memory to make money.
Right. And then Lou Montulli comes in. He was this 23-year-old engineer at Netscape at the time.
23. Wow.
Yeah. And he comes up with the solution that flips the entire paradigm. Instead of keeping the memory on the server, he pushes the burden of memory to the edge of the network.
Meaning he pushes it to the user's local computer.
Exactly. He essentially invented a digital token system.
Okay, so how does that mechanically work?
So when you connect to a server, the server sends back your requested web page, right?
Right.
But tucked inside that response is a new command.
The set cookie command.
Yes. It instructs your browser to write this tiny plain text file to your own hard drive. And it just contains a unique string of characters.
So it acts like a digital wristband.
Oh, that's a good analogy.
Yeah, like you walk into a club, they check your ID, and they put a wristband on you. And every time you go to the bar, you don't have to show your ID again. You just flash the wristband so they know you're already verified.
That is exactly how it works. The genius of it is in the automation. Because the next time you click a link on that site, your browser automatically reads that text file and attaches it to your outgoing request.
So the server doesn't actually have to remember you at all. Your own browser is constantly reminding the server who you are.
Right. The server just runs a super quick matching operation. It sees the unique string in your cookie, matches it to the temporary cart file in its database, and boom, reconstructing the state is totally effortless.
And that's the HTTP picky.
That's it. It was meant to be this simple, elegant fix for a very localized problem.
But the architectural decision to store tracking identifiers on the client side just blew the doors wide open.
It opened a Pandora's box that literally nobody fully anticipated in 1994.
Because it assumes a first-party relationship. It assumes I am walking into your store, you hand me a ticket, and you recognize me while I'm inside your specific store.
Right.
But the internet didn't stay a collection of isolated stores. It became this deeply intertwined mesh. Which leads to my next question. How does an innocent tool explicitly designed just to help me buy a sweater turn into this massive tracking apparatus?
Well, the mutation happened because of how web pages are physically constructed, and this is where we get into third-party cookies.
Okay, lay it on me.
So when you load a modern news article, you are not downloading a single monolithic file from the publisher's server.
It feels like I am.
Right, it looks seamless. But you're actually downloading a framework like an HTML skeleton that contains dozens of blank spaces.
Blank spaces for what?
For content that lives somewhere else. The publisher's code basically instructs your browser to go out and fetch the missing pieces from dozens of different external servers.
Oh, I see. So I'm fetching, like, an image from a content delivery network.
Yes, or a comment section from a plugin provider. And most crucially, advertisements from automated ad exchanges.
So the page is less like a solid document and more like a mosaic being assembled in real time right on my screen.
A mosaic is the perfect way to visualize it. And here is the catch. Every time your browser reaches out to one of those external ad servers to fetch a tile for the mosaic, that external server gets the opportunity to drop its own cookie on your machine.
Wow. So even though I never explicitly went to the ad server's website, they still get to put a wristband on me.
Exactly. That is the core mechanism of the third-party cookie. The ad network is the third party. You have zero direct relationship with them.
I just wanted to read the news.
Right, you went to read the news. But because the ad network served an element onto your page, they slip a digital tracker into your pocket.
And I'm guessing this tracker doesn't just stay on the news site.
Not at all. And this is how the tracking becomes completely systemic. That ad network doesn't just serve ads to that one news site. They have their code embedded on millions of websites.
Like sports blogs, medical forums, recipe sites.
Exactly. E-commerce, storefronts, you name it.
And because my browser is programmed to just blindly hand back a cookie to whatever server originally set it, the second I visit that sports blog, my browser says, oh, I need to fetch an ad from this network. Here's the cookie you gave me an hour ago on the news site.
Yes. And the ad network suddenly realizes, wait, User 9876 was just reading about lower back pain on the medical forum, and now they're looking at golf clubs on the sports blog.
So they just stitch those totally disparate data points together.
They stitch them into a highly detailed, persistent behavioral profile across totally unrelated sites.
That is wild. But wait, what if I'm using an ad blocker?
Yeah.
Or what if the site doesn't have visible banner ads?
Well, the ad tech industry quickly realized they didn't even need to show you a visible advertisement to do this.
Oh.
That's where they invented the one-by-one tracking pixel.
Also known as a web bug, right?
Yeah, a web bug. This is a transparent image file, literally a single pixel wide, embedded completely invisibly on the page.
So I can't see it at all.
You are totally blind to it. Its only purpose is to force your browser to make a request to the ad server so the server can drop or read a cookie.
And that logs my exact trajectory across the web.
Exactly. And it gets even more advanced now with things like browser fingerprinting and DOM telemetry.
Browser fingerprinting, like
Yes.
they read the specific hardware I'm using.
Yeah, your screen resolution, your installed fonts, your operating system version. Even if you block cookies, they can identify your unique device fingerprint and build massive cross-site behavioral profiles without your explicit knowledge.
That structural reality completely changes the economics of the internet. Because once platforms realized they could build these incredibly dense psychographic profiles of users across thousands of websites, the product changed.
Right, the product being sold was no longer just ad space. The product was predictive human behavior.
And to make those predictions more accurate, they needed more data.
Which meant they needed us to spend more time on their specific platforms. I mean, tracking is utterly useless if the user gets bored and closes the tab.
So once the technical infrastructure could track you flawlessly across the web, the platforms realized they needed to design an environment you'd never want to leave.
They had to eliminate all the friction.
Right. And this brings us to a massive evolutionary leap from Web 1.0 to Web 2.0. Because in the early web, the interaction loop was synchronous and, honestly, highly friction-heavy.
It really was. Every single action required a full page reload.
Yeah, if I'm on an early message board and I want to see if someone replied to my post, I have to physically drag my mouse up and click the refresh button in the browser.
And then you wait. The browser drops the connection, sends a totally new DET request, the screen flashes white, and the entire HTML page renders again from top to bottom.
That's incredibly clunky.
It was a huge interruption to the user flow. It forced you to wait.
Yeah.
But in the early 2000s, engineers standardized a set of technologies that we broadly refer to as AJAX.
That's asynchronous JavaScript and XML, right?
Exactly. Specifically, there's this thing called the XML HTTP request object, and it allowed the browser to communicate with the server in the background, completely without disrupting what the user was currently seeing on the screen.
So the browser learns to basically whisper to the server.
Yes, exactly.
So instead of reloading the whole page, it just asks for the tiny little string of text that makes up a new comment, or the updated number for a like count.
Right, and JavaScript seamlessly injects it into the existing document object model, the DOM on the fly.
The friction is entirely eliminated. You don't even notice it happening.
And here's where it gets really interesting, because the asynchronous nature of AJAX is what made the infinite scroll physically possible.
The infinite scroll. The bane of my existence.
Well, before AJAX, every web page had a physical boundary at the bottom, usually marked by a button that literally said next page.
Oh, I remember those. You'd get to the bottom of the form and have to click page 2, page 3.
Right, and that button served as a crucial cognitive checkpoint. It forced the user to make an active, conscious decision. Am I getting enough value out of this to initiate a new request?
But the infinite scroll weaponizes the DOM. It dynamically appends new elements to the bottom of the page the moment your scroll bar hits a certain threshold.
The bottom of the page ceases to exist.
There is no cognitive checkpoint. You never have to ask yourself if you want to keep going, because the decision is just made for you in the background.
It removes all the natural stopping points. And we really have to look at what happens when you combine this frictionless delivery system with algorithmic sorting.
Because early social feeds were strictly chronological, right?
Yeah, you saw what your network posted in the exact order they posted it.
But chronological feeds have a finite end. Eventually, you catch up.
Okay.
And honestly, they often contain really boring material, like what someone had for lunch.
Right. But to maximize dwell time, which rapidly became the absolute ultimate metric of success in the industry, chronological sorting was replaced.
replaced by recommendation algorithms designed purely to optimize engagement.
Exactly. And this is where we cross the line from computer science directly into behavioral psychology.
Yeah, when you look at the mechanics of the pull-to-refresh motion on your phone or the algorithmically sorted feed, it maps perfectly onto B.F. Skinner's operant conditioning research from the 1950s.
It really does. Skinner's work with variable reward schedules is the exact psychological blueprint for modern platform design.
So let's break that down for the listener. Skinner put pigeons in a box with a lever, right?
Yes, the famous Skinner box.
And if the pigeon pecks the lever and gets a food pellet every single time, which is a fixed reward schedule,
Yeah.
the pigeon quickly figures out the system.
Right. It eats when it's hungry, and then it just ignores the lever. The behavior becomes predictable and easily satiated.
But when Skinner altered the mechanism so the reward was randomized.
Ah, the variable reward.
Right. Sometimes one peck yields a pellet, sometimes it takes 10 pecks, sometimes 100. The pigeon's behavior drastically changes.
It becomes completely obsessive. It pecks the lever incessantly.
Because the unpredictability is intoxicating.
Exactly. The uncertainty of the reward creates a massive spike in dopaminergic activity in the brain. Anticipation is far more neurologically stimulating than the actual reward itself.
So the algorithmic feed is literally a digital Skinner box.
It is. The pull-to-refresh mechanism is functionally identical to pulling the lever on a slot machine in Vegas.
That slight engineered delay as the loading icon spins at the top of the app.
Yeah.
That is the spinning of the slot machine wheels.
Yes. You have absolutely no idea what you were going to get.
It might be a totally boring update from a relative, or it might be an inflammatory news story, or, a notification that a photo you just posted has suddenly received a massive influx of social validation.
And they weaponize that social validation and FOMO, the fear of missing out, to keep you hooked. And because the system is constantly running A/B tests on millions of users simultaneously, it isn't just guessing what will trigger your dopamine response. It knows. It is running DOM telemetry. It is measuring the exact XY coordinates of your mouse cursor.
Wait, really? It measures my mouse movements?
Oh, absolutely. It measures the millisecond hesitation before you scroll past an image. It knows that if it shows you, say, 3 mundane posts followed by one highly enraging post, your dwell time increases by 14%.
So it is constantly refining this variable reward schedule tailored specifically to your unique psychological profile.
Yes.
Wow.
Which means the system is no longer just tracking us to serve an ad for a sweater.
It's actively modifying our behavior.
Exactly. And this dopaminergic feedback loop isn't just some clever marketing trick. It represents a stunning, tragic reversal of one of computing's original philosophies.
Right. And to really grasp the mechanics of that manipulation, we have to talk about cybernetics.
Cybernetics. It's a term that gets thrown around in science fiction a lot, but it has a very rigorous mathematical origin that perfectly explains what is happening to us today.
So let's introduce Norbert Wiener. He coined the term in the 1940s, right?
Yes, Norbert Wiener. He was a mathematician working on anti-aircraft predictors during World War II.
Anti-aircraft predictors.
Yeah, the problem was that airplanes moved way too fast for human gunners to accurately track and fire upon.
Oh, so they needed a system to lead the target?
Exactly. Wiener realized that to hit a fast-moving target, you had to build a system that constantly measured its own errors and adjusted itself in real time. This is the essence of a cybernetic feedback loop, regulatory systems and feedback.
A classic non-military example that I think makes this super clear is a thermostat.
Oh, the thermostat is the perfect analogy.
Right, because you set a goal, say 72 degrees. The thermostat measures the current ambient temperature, calculates the difference between the current state and the goal, applies an input like turning on the furnace, and then continuously measures the environment again.
It's a closed loop. Measure, act, measure, adjust. Over and over until the goal is met.
And Wiener's theories heavily influenced the early pioneers of computing in the 1960s, specifically people like J.C.R. Licklider.
Licklider is a huge figure here. He wrote this seminal paper called Man-Computer Symbiosis.
Because up until that point, computing was basically just batch processing.
Right, you handed a stack of physical punch cards to an operator, and you got a printout the next day. There was zero real-time interaction.
But Licklider envisioned applying a cybernetic loop to the human mind itself. He wanted the computer to act as a real-time auxiliary cortex.
So you sit at a screen, you type a command, The computer processes the complex math and displays the result instantly.
You evaluate the result, adjust your hypothesis, and type the next command. You are in a continuous flowing dialogue with the machine.
But, and if we connect this to the bigger picture, this is the critical distinction in Licklider's vision, the hierarchy of control.
Right. In his model, the human being is the active agent.
Yes. The human sets the goal, and the computer is the tool augmenting the human's intellect within that loop. The human drives the cybernetic system.
The human is in charge. Which brings us to the profound structural shift of the modern web, something we can call the cybernetic inversion.
The cybernetic inversion of Web 2.0, because the architecture of Web 2.0 and the algorithmic feed fundamentally invaded Licklider's hierarchy.
Today, in the era of the infinite scroll, the user is no longer the active agent setting the goal.
The machine is the active agent.
So if we look at this through the lens of control theory, modern recommendation engines operate like a highly advanced PID controller, a proportional integral derivative controller.
Exactly. The algorithm has a predefined goal set by the platform's engineers. Maximize user dwell time to maximize ad impressions.
And the user is just sitting stationary, staring at a screen. The algorithm applies an input. It serves a piece of content.
Then it measures the feedback. It monitors your scroll speed, your micro pauses, whether you expand the comments, or if you immediately navigate away.
So the human being is now the plant in the control theory diagram. We are the environment being manipulated.
We are. The algorithm measures the error rate between your actual behavior and its goal of keeping you engaged. It recalculates the weights of its neural network, and it adjusts the next piece of content it serves to pull your behavior closer to its mathematical objective.
So we are no longer using the machine's cybernetic loop to explore the world. The machine is using a cybernetic loop to regulate us.
We have literally become the thermostat's environment. The machine is applying heat to elicit a specific, predictable response.
And the heat it applies isn't random.
No, not at all. The algorithm quickly discovers, purely through the cold mathematics of trial and error, which inputs generate the most prolonged biological responses.
Which perfectly transitions us to the broader societal implications of this entire architecture. Because when you apply this inverted cybernetic loop to 3 billion people simultaneously, the consequences stop being about individual wasted time.
Right, it becomes about the fundamental fracturing of society.
Because the algorithm optimizes for engagement. It doesn't optimize for truth, nuance, or civic cohesion.
Which leads us directly to the mechanics of the filter bubble, an extreme algorithmic sorting.
So let's break down filter bubbles.
A filter bubble is basically the inevitable result of an algorithm prioritizing your comfort and your engagement over a holistic view of reality.
The system learns what viewpoints you agree with.
It learns what aesthetics you prefer, what topics keep you logged in, and then it systematically isolates you. It puts you in a padded room composed entirely of your pre-existing opinions.
Actively suppressing dissenting information or challenging viewpoints that might cause you to, get annoyed and close the app.
Exactly.
Now, I want to challenge this with a pushback. I want to play devil's advocate here, because this is where the debate often gets really muddy.
Okay, let's hear it.
The common counterargument is network homophily. Human beings have always clustered with people who share their beliefs. Birds of a feather flock together, right? If I'm highly conservative, I probably subscribe to a conservative magazine and hang out with conservative friends. If I'm deeply progressive, I live in a progressive neighborhood and read progressive literature. We naturally seek out echo chambers. So how is algorithmic sorting any different or more dangerous than standard human nature?
It's a great question. The distinction lies in the mechanism of consent and visibility. Network homophily is an active, conscious choice.
I chose to buy the magazine.
Right. You are aware that you are buying a specific magazine with a specific editorial slant. You know there is a broader world outside of that magazine. Algorithmic curation, however, is mathematically enforced segregation, and it is entirely invisible.
I see.
The algorithm actively hides content from you without your knowledge. You don't realize you are in a bubble because there are no walls you can see. The algorithm presents a hyper-curated, isolated feed and frames it as the objective state of the world.
And the more time you spend inside that invisible bubble, the more susceptible you become to what sociologists call epistemic drift.
Yes. This raises an important question. How does this affect our shared reality?
Well, epistemic drift is this gradual process where a user's fundamental baseline of what constitutes reality, what facts are agreed upon, what issues are mainstream versus fringe, It slowly drifts away from the center as they are pulled deeper into these isolated ecosystems.
And we must be incredibly precise and strictly impartial about why this happens. We want to be clear to you, the listener, right now. The algorithm does not possess a political ideology.
Right. Neither left-wing nor right-wing.
Exactly. It is completely agnostic to the semantic meaning of the content. It does not lean left and it does not lean right. It doesn't care if a video is a complex geopolitical analysis or a baseless conspiracy theory. It only sees variables and weights.
It evaluates a piece of content based purely on its viral coefficient and its dwell time retention rate.
Just the cold mathematics of engagement. And here is where human biology works against us.
Because studies in network dynamics and sentiment analysis consistently show that nuanced, moderate content does not generate high engagement.
No, it doesn't. What stops the infinite scroll? Emotion. Specifically, outrage and moral contagion.
Because outrage is biologically sticky. If a post triggers anger or moral indignation, your heart rate elevates.
You are mathematically guaranteed to spend more time staring at that post. You are highly likely to leave an angry comment, and you are far more likely to share it to signal your own moral stance to your in-group.
And the PID controller observes this data spike. It registers that the outrage variable heavily correlates with its goal of maximizing dwell time.
So the algorithm naturally weights emotional triggers higher. It discovers that serving you an exaggerated, polarizing caricature of the opposing viewpoint keeps you engaged longer than serving you a thoughtful critique.
It universally funnels users away from the nuanced middle grounds and toward the extremes, simply because the extremes are structurally better for the business model.
It creates an amplifying feedback loop of radicalization. The more outraged you are, the more data you generate. The more data you generate, the better the algorithm gets at predicting exactly which micro-targeted grievance will trigger you next.
It's like a funhouse mirror. You think you are looking at a clear reflection of the real world, but it's actually a distorted, highly exaggerated version of your own biases fed back to you.
Fed back to you until you forget what the outside world even looks like. If you stare into that funhouse mirror for 5 hours a day, year after year, the concept of a shared objective reality completely collapses.
You literally inhabit a different informational universe than your neighbor.
The architectural choices of the network, from Ontulli's HTTP cookie to the invisible tracking pixels building DOM telemetry maps, to the AJAX asynchronous loading, to the cybernetic recommendation engines, all of it stacks on top of each other.
They operate in concert to create an environment where a shared baseline of facts is mathematically impossible to sustain.
The network has transitioned from a neutral utility for transmitting data into an active participant in shaping human cognition.
So what does this all mean? We've covered an immense amount of ground today.
We really have.
We trace the lineage of the modern web, from Tim Berners-Lee's amnesiac stateless HTTP protocol to the moment Lou Montulli innocently invented the cookie to solve the shopping cart problem.
And we saw how the advertising industry weaponized that memory, using third-party pixels and fingerprinting to build exhaustive behavioral profiles.
We broke down how AJAX removed the friction of page reloads, enabling the frictionless dopamine loops of the infinite scroll, which algorithms then packed with variable reward schedules straight out of D.F. Skinner's laboratory.
And finally, we dissected the complete cybernetic inversion, how the machine now uses control theory to regulate human behavior, prioritizing outrage and fracturing our shared reality simply to extract data.
It is a profound structural reality that most of us interact with hundreds of times a day without ever seeing the underlying mechanisms.
And I think this leads us to a final critical perspective to consider, something for you listening to really mull over.
Yeah.
If you look at the broad sweep of human history, for 5 millennia, our species has been in the business of externalizing its memory.
Right. From the Inca using complex knotted cords called quipu to store data,
To the printing press allowing us to externalize our history into books.
and the early digital search engines externalizing our encyclopedias. We have always outsourced our memory to our tools.
But the architecture we've discussed today crosses a terrifying threshold. With recommendation algorithms actively sorting our reality, running A/B tests on our emotional triggers, and deciding exactly what stimuli reaches our optic nerves every millisecond to maximize dwell time.
We have to ask a much deeper question. Are we no longer just externalizing our memory? Are we beginning the process of externalizing our very cognition to the machine?
When a cybernetic loop that you do not control is deciding what information you consume, it is ultimately shaping how you think. The tool is no longer passive.
Which leaves you with one imperative the next time you pick up your device. Who is really the active agent in your digital journey? who is really in control.
Are you exploring the network, or is the network exploring you?
Keep questioning the systems you interact with every single day.